So what I'm going to show you in this video is drawing the Lewis dot diagram for a little bit of trickier examples. And so the first one that I'm going to do is oxygen. Okay. So for all of these, the first thing that you need to do is you need to determine the number of valence electrons. Well, oxygen has 6 valence electrons, but since there are 2 oxygens, that's going to be 12 valence electrons. Okay. Your next step, you're going to take your 2 atoms and you are going to have them share a pair of electrons. And now to fill out the rest of it, I'm going to put oxygen needs 6 more, so 2, 2, and 2. Make sure not to put 2 right here, please. And then 2, 2, and 2. Now, if I count, normally I would be done, but let's count. 2, 4, 6, 8, 10, 12, 14. Well, that's too many electrons. So what I actually need to do is I'm going to form a double bond. Okay, and so that double bond represents 2 electrons still, but that gives this oxygen 2 and that oxygen 2. And so what I'm then going to do is I'm going to erase those 2, and let's count now. 2, 4, 6, 8, 10, 12. That's great. So you need to follow those steps, all of those steps I did before I added the double bond. So don't just blindly add double or triple bonds, really go through and make sure you understand it. Okay. For the next one that I'm going to do, I'm going to do carbon dioxide. Well, carbon dioxide, carbon has 4 valence electrons, oxygen has 12, and so that's a total of 16 valence electrons. Okay, so I'm going to draw this out. I'm going to have them sharing 2 electrons. Okay, then I'm going to draw the Lewis dot diagram here. So it's going to be 6 for oxygen, so it has 8. Carbon has 2, 4 already, so it just needs 4 more, 2 and 2. Then this has 6. Okay, obviously this isn't going to be the final product, because if this were the final product, it would be bent, but let's check it. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. I'm using too many valence electrons. So what I'm going to do is I'm going to add a double bond here, which means that I can then go and I can erase these 2 and those 2. So let's count again. 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm still using too many electrons. So what I need to do is draw another double bond. So I'm going to erase these 2, I'm going to erase these 2, and let's see if I'm good now. 2, 4, 6, 8, 10, 12, 14, 16, and I'm good to go. Alright? For the next one, I'm going to do SO3. So this is number 4. For SO3, S has 6 valence electrons, oxygen has 6 as well, so it's a total of 24 valence electrons. Okay? So if I were to draw this, if I were to sketch this out, I don't know what it's going to look like, so I'm just doing the 3 like that. I'm not doing 3 down necessarily. I don't know. Okay, but I'm going to add 6 electrons to this oxygen. I'm going to add 6 to this one. I'm going to add 6 to this one. And then I'm going to add 2 to this sulfur right there. Okay, so I'm using 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'm using too many valence electrons. And so what I actually need to do is I need to erase 2. I need to erase these 2, and I'm going to add a double bond. Now, here's the tricky part. This is a case of resonance because I could have put the double bond here or I could have put it here. And so what I'm going to draw is I'm going to draw those 2 other versions. I'm going to draw the double bond on the left-hand side, so make sure to show all your dots and not be lazy with that. And then the other version would be this. Now, I'm drawing this not because these 3 things actually exist, but because that is the easiest way for me to represent the resonance that occurs in sulfur trioxide. This is resonance. And so how I explain this in class, one of these doesn't exist. Instead, it's a blending of them. So if I had the color white, and I had the color blue, and I had the color yellow, if I blended those together, what I would get would be light green. And that is what I actually would get if I blended these together. That's what SO3 actually looks like. Another way of thinking about this is from a numerical point of view. If this is a single bond, and this is a single bond, and this is a double bond, if I'm going to average these, 1 plus 1 is 2 plus 2 is 4, so that's 4/3, each bond is 4/3 of a bond, so 1.33 worth of a bond. Well, I don't know how to represent 1 and 1.33 of a bond, and so instead, because each of these would be 1.33, instead what I'm showing is all three of these and saying, well, it's not just one of these, it's all of these combined and averaged.